class I explained about the concept of thin cylinders. So if the thickness of the cylinder is less than 1 by 20th of its internal diameter, then it is called as a thin cylinder. And now two types of
Sir,
stresses. Yes,
Sir,
yes, please. Really?
sir, internals question paper doubt ಇದೆ sir ಅದು ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡೋದು.
ಆಯ್ತಾಯ್ತು, ನಾನು ಇದು ಕ್ಲಾಸ್ ಆದ್ಮೇಲೆ ಲಾಸ್ಟ್ 10 minutes ಅಲ್ಲಿ ಹೇಳ್ತೇನೆ, ಆಯ್ತಾ? ಕೇಳಿ.
ಹಾ ಸರಿ ಸರ್.
So in the case of thin cylindrical vessels, two types of stresses will develop. One is circumferential stress, which acts along the circumference. Another are the hook stress. Another one is the longitudinal stress. So yesterday I explained you how to derive the expressions for those two things. So circumferential stress is given by sigma 1 is equal to PD divided by 2 times T. Okay. Whereas longitudinal stress is given by PD divided by 4 times T. That means circumferential stress is 2 times the longitudinal stress. Then maximum shear stress is given by PD by 8 times T. So these three expressions we have seen, and we did some problems of finding the stresses as well as thickness. So in the case of thin cylinder, the maximum permissible stress will be the circumferential stress. You have to keep that in mind, which is given by PD divided by 2T. So if they ask you to find the thickness by giving maximum permissible stress, you have to use that equation sigma 1 is equal to PD divided by 2T, and we have to find the value of that thickness T. Now today we will see another thing there in the case of thin cylinder, how to find the volumetric strain in the case of thin cylinders. So you can directly go to 750 page. So I am going to explain in this only because it is very clear. All the steps are there in this. So that's why I am going to refer this one only. So you have to stick on to these notations only. So whatever we have covered till yesterday, next topic is this, because in this book there are so many topics. You have to note on the page number. So 750. So R.K. Bansal 750 page number. So in that this is there. So we will see how the volumetric strain in the case of a thin cylinder subjected to internal pressure. So normally the pressure will be fluid pressure, because in cylinders pipes you will be having some liquid will be flowing. So that liquid or gas, that is a fluid. So that is why we are going to take the internal pressure as the fluid pressure. So in the last chapter in simple system strains also we have derived the expression for volumetric strain in 3 cases. So hope you have understood that. First one is for rectangular block. So that is delta V by V. So volumetric strain means epsilon V. So epsilon V is nothing but your delta V by V. Change in volume divided by initial volume. That is called as the volumetric strain. And we derived the expression for volumetric strain in cylindrical rod also, or bar, and conical bar. I think in sphere. So those 3 we did. So here also we have to use the same procedure, but we are going to use the concept of principal stresses and strains here to get the expression for the volumetric strain in thin cylinders. So this is another important derivation. So they may ask you to derive. So derive the expression for the change in volume of a thin cylinder or cylindrical shell which is subjected to internal pressure. Okay, so that is the question. Now let us see how we can derive the expression for that. So here let us take P as the internal pressure. So these are the notations we are going to follow. P is the internal pressure, L is the length of the cylinder, D is the internal diameter of the cylindrical shell, T is the thickness of the cylindrical shell, E is Young's modulus of the material of the shell or the cylinder. You can call either the cylinder or shell. Then sigma 1 is the hook stress, sigma 2 is the longitudinal stress. So please note that these two are very important. sigma 1 acts along the circumference, whereas sigma 2 acts along the longitudinal direction. That means stresses always act normal to the plane. You keep that in mind. So these two are perpendicular to each other. Sigma 1 and sigma 2, they are perpendicular to each other. Both are tensile. So that also I told. So both the stresses are tensile stresses, sigma 1 and sigma 2. Mu is the Poisson's ratio. Let us take delta D as the change in diameter due to stresses that is going to set up in the material. Delta L is the change in length. So you are having two things here. One is delta D, change in diameter. Delta L is the change in length. Delta V is the change in volume. So these are the notations we are going to follow. So whenever the pressure inside the thin cylinder increases, and the pressure increases, naturally volume reduces. That I told in the beginning itself. More the pressure, lesser will be the volume. So there will be some change in volume. So when the pressure inside a cylindrical shell increases, volume reduces. So the change in volume will be your delta V. Change in diameter is delta D. Change in length is delta L. Okay. Now let us see how we can derive. So simple, you have to understand some 4 or 5 steps are important here. Important derivation, or they may give a problem on this. So first we have already seen that the expressions for sigma 1 and sigma 2. So sigma 1 is hoop stress or circumferential stress. Sigma 2 is the longitudinal stress. So we have derived these two. Sigma 1 is PD by 2T. Sigma 2 is PD by 4T. Now, one important thing here is we are going to use that generalized Hooke's law now. Generalized Hooke's law we are going to use now. So as I already told, sigma 1 and sigma 2, they are mutually perpendicular to each other. The directions will be mutually perpendicular. So sigma 2 acts along the longitudinal direction, whereas sigma 1 acts along the circumferential direction. They will be mutually perpendicular to each other. Once they are mutually perpendicular to each other, you can find out the strain in one of the direction by using generalized Hooke's law. So all of you know about generalized Hooke's law, which I have explained in the first chapter. If there are stresses acting in all the 3 directions, sigma x, sigma y, sigma z, you can find out the strains in the 3 directions. So epsilon x, epsilon y, epsilon z. So epsilon x was 1 by E into sigma x minus mu times sigma y plus sigma z. That we have to remember. Okay, so that is generalized Hooke's law, assuming all tensile. I have given the sketch for all tensile stresses. Here, since both these two are tensile stresses, sigma 1, sigma 2 are tensile stresses, only 2 stresses we are considering. We are not considering the third one. So that means what you can say is the sigma 1 is taken as sigma x, sigma 2 is taken as sigma y. That's all. Okay. Now, if you apply that generalized Hooke's law here, epsilon 1 is nothing but epsilon x. So I am taking circumferential strain. Circumferential strain as the epsilon 1. When you are writing the expression for circumferential strain epsilon 1, so it is given by sigma 1 by E. Sigma 1 by E is in that direction. Strain in that direction, and strain in the other direction, or strain due to sigma 2 also we have to consider. So strain due to sigma 2 stress in the direction of 1, in the direction of sigma 1 will be minus mu times sigma 2 by E. So this is lateral strain part. This is linear strain part. So this I have explained when I did that generalized Hooke's law. So same concept is used here. Okay, suppose if you are writing epsilon x is equal to sigma x by E minus mu times sigma y by E minus mu times sigma z by E. So that is how we are writing. But here only sigma 1, sigma 2, only 2 stresses are there. Sigma 3 is not there. Okay. So in that case, only 2 terms will come here. So x is replaced by 1, let us say circumferential strain. Now substitute for sigma 1 and sigma 2 using these two. So sigma 1 is PD by 2T, sigma 2 is PD by 4T. So substitute those two here. So what you will get? Let us see. So substitute and simplify. So you will be getting PD by 2TE minus mu times PD by 4TE. So you can take PD by 2TE common here. So 1 minus mu by 2. So you are going to get 1 minus mu by 2. So what we have done is, first we have applied generalized Hooke's law. Then we have substituted for sigma 1 and sigma 2. formula. Okay, that's all we have done. Next, similarly, longitudinal strain. So circumferential strain is epsilon 1. Longitudinal strain, I will take it as epsilon 2. So they are mutually perpendicular. So it is given by sigma 2 by E minus mu times sigma 1 by E. So sigma 2 by E is the linear strain. Mu into sigma 1 by E is the lateral strain. Okay. So it's a combination. So we have to take in the reverse. That means sigma 1 is replaced by sigma 2 is replaced by sigma 1 in the formula. So then once again substitute for sigma 1 sigma 2 here and simplify, you will be getting this PD by 2TE into half minus mu. You are going to, it's here 1 minus mu by 2, here half minus mu. So just after substituting and simplifying. Now, so this is one part. Using generalized Hooke's law, we have got the expressions for epsilon 1 and epsilon 2. They are the circumferential strain and the linear strain or longitudinal strain. Next, using the definition of strain, you can write the expression now. So how circumferential strain is defined? So we know that strain is nothing but change in dimension divided by initial or original dimension. So since we are calculating circumferential strain, we have to take epsilon 1 as epsilon 1 is your circumferential strain using the definition. The first we have written using the generalized Hooke's law. Second part we are writing using definition. Then we are comparing. So epsilon 1 is given by change in circumference due to pressure divided by original circumference. This is as per the definition. Because we are finding circumferential strain, we have to take the change in circumference divided by original circumference. So what is change in circumference? It is final circumference minus initial or original circumference divided by original circumference. So now I have assumed that delta D as the change in diameter. So what will be the final diameter? Then D plus delta D. So your final circumference will be pi into D plus delta D minus original or initial circumference is pi into D divided by pi into D. If you simplify this, you will be getting delta D by D. So delta D by D is nothing but change in diameter divided by original diameter. Because pi is a constant, so it will get cancelled. And what you are going to get, epsilon 1 you are going to get as delta D by D only. Please understand this. So next, similarly, you have to equate now. So from generalized Hooke's law, this is the expression for epsilon 1. From first principles or from definition, this is the expression for epsilon 1. Now you equate these two. Both are same, 17.6 and 17.9. They are same. So equate them. So delta D by 2 is equal to PD divided by 2T into 1 minus mu by 2. Or change in diameter. If you want change in diameter delta D, it will be D comes to this side. PD square divided by 2T into 1 minus mu by 2. Okay. So this is the expression for change in diameter. You have to remember this. So you have to remember this for doing problem. If a problem is given, calculate the change in diameter, you have to use this formula directly because they will give all the data. P you will be knowing, T, D, mu, everything will be given, E, everything will be given. Directly you can use this formula. So remember this formula for calculating the change in diameter in the case of a thin cylinder subjected to internal pressure. Now, so this is the expression for change in diameter. So to get the expression for change in diameter, we have equated the expression for circumferential strain using generalized Hooke's law and using definition. That's all. Similarly, how to find change in length? So this is change in diameter, delta D. Now to find change in length, we have to take the definition of longitudinal strain or linear strain along the length of the cylinder. Once again, epsilon 2, which is nothing but the longitudinal strain, it is given by change in length divided by original length. So what is your change in length? Delta L. Delta L is the change in length divided by original length is L. So delta L by L. Now this should be equated to your epsilon 2, which you have got from generalized Hooke's law. That means this PD by 2T into half minus mu. That is, you can equate 17.8 and 17.12. Okay, you can equate these two, you will get delta L. So delta L by L is equal to PD by 2T into half minus mu. See, so therefore delta L will be PDL divided by 2T into half minus mu. So this you have to remember for calculating change in length. So this is the formula for calculating change in diameter. This is the formula for calculating change in length. Now let us see how we can calculate volumetric strain. As you know, volumetric strain is defined as change in volume divided by original volume, epsilon V. You can call it as epsilon V, delta V by V. Now let us see how we can calculate that for a thin cylinder subjected to internal pressure. So change in volume is nothing but final volume minus initial volume, okay, or original volume. So what is the original volume? Original volume is, it's a cylindrical shell, you know. So cylindrical shell means area will be area into length is the volume. So what is the area of a cylinder? It is a circular cross section. So pi d square by 4 is the area into L. So this is the volume of a cylindrical shell or a thin cylinder. Now, what is the final volume? So final volume is nothing but final cross-sectional area multiplied by final length. So what we have taken, final diameter is d plus delta d, you know. So we have taken final diameter as d plus delta d. So what you have to take, final area will be pi by 4 into d plus delta d whole square into final length will be L plus delta L. So please see the difference here. So when you are calculating final volume, pi d square by 4 is the area into L is the length. So this is original volume. When you are finding final volume, d should be replaced by d plus delta d, L should be replaced by L plus delta L. Now you have to simplify this, multiply all these. So when you multiply, you are going to get so many terms like this. Okay, here there are 3 terms, here there are 2 terms. So totally 6 terms you are going to get. Among these 6 terms, in whatever term you have got this delta, is these terms are neglected because they will be very small. So delta d square into L term is neglected. Delta L into delta d square term is neglected. Then 2d into delta L is neglected. See here. So that means product of small, this becomes smaller quantities because we know that delta L and delta D, they are very, very small. When they are very small, their product will be still small. Product or square. So whatever is there. So all those terms you can neglect. So if you neglect those terms, you'll be getting finally only 3 terms. So neglecting this term, so you can neglect this delta D square into delta L term, delta D into delta L term, and also you can neglect this delta D square into L term. So remaining terms only we have to write. So those 3 terms are taken. Next, change in volume. This becomes your final volume. So change in volume will be delta V will be this minus this. So final volume minus initial volume. Final volume is this minus initial volume is this. So if you subtract this minus this, so this first term will get cancelled with the last term, and only these 2 will be remained. So you will be getting this much. So this is the change in volume. You can practice this. You will get simple steps. So initial volume or original volume and final volume we had to calculate. Deduct the original volume from the final volume by neglecting the smaller quantities. Smaller quantities means delta D, delta L, they are all very small. Product of them will be small. So only one delta D, delta L is there when you have to take the term. Product if it is there, or square term if it is there, that you have to neglect. So now change in volume, final volume minus original volume. So if you simplify that, you will get only 2 terms here. Next, how do you get volumetric strain? Volumetric strain is delta V, that is change in volume, divided by original volume. So change in volume is this, original volume is this. So if you divide that and simplify, you will be getting, see, 2 into delta D by D plus delta L by L. So this is what you are going to get. So what is delta D by D? Delta D by D is nothing but your epsilon 1. Just now we have proved it. Delta L by L is nothing but your epsilon 2. Okay. So initial, that is circumferential strain is epsilon 1. Longitudinal strain is epsilon 2. So delta D by D is nothing but epsilon 1. Delta L by L is nothing but epsilon 2. So those things we have proved. It is written here. So then what you can do is you substitute for epsilon 1 and epsilon 2 from these 2, which we have already have. So this is epsilon 1, this is epsilon 2. If you substitute that and simplify here, finally you are going to get the expression for volumetric strain. So the expression for volumetric strain, so I have substituted here. See, this is the expression for epsilon 1, this is the expression for epsilon 2. You just substitute and simplify, you will be getting finally So delta V by V, that is volumetric strain, is equal to PD by 2ET into 5 by 2 minus 2 nu. This is what you are going to get. So therefore, what will be delta V? Delta V will be V into this, V into this, or V into 2 epsilon 1 plus epsilon 2. So delta V by V we can get using this formula. After getting this delta V, you can find out delta V by V. We can find out delta V by multiplying this by V. Okay, that is how the problem will be done. So numerical problem, if they ask, that will be done using that. So here what we have done is, first, this is an important derivation. You have to practice. Okay. So these are the notations we are going to use. First, we have taken the expression for circumferential strain, stress, that is sigma 1, or the hoop stress, PD by 2T. Longitudinal stress is PD by 4T. They will be mutually perpendicular to each other, sigma 1 and sigma 2. Then we have applied the generalized Hooke's law, which gives the strain in one direction due to stresses in two directions. That means sigma 1 will be in that direction only, whereas sigma 2 will be in the perpendicular direction. In the perpendicular direction, if it is tensile, in this direction it becomes compressive, therefore minus has to be taken. So this is the linear strain term, this is the lateral strain term. So if you have to add these two to get epsilon. Add means in between minus will be there. So this is the expression. After substituting for sigma 1, sigma 2 and simplifying, we are going to get the expression for epsilon 1 like this. That is the first part. Similarly, epsilon 2, that is longitudinal strain, once again using Hooke's law, generalized Hooke's law. So strain due to sigma 2 minus mu times strain due to sigma 1. Okay. So that once again substitute and simplify, you will get this. Then from definition, epsilon 1 is given by change in circumference divided by original circumference, because it is the circumferential strain. So that if you simplify, you are going to get delta D by D. So then equating this and this, you will be getting delta D by D is equal to PD by 2T into 1 minus mu by 2, or change in diameter delta D will be multiply this. So PD square by 2T into 1 minus mu by 2. Okay. Similarly, longitudinal strain, according to the definition, it is change in length divided by original length, which is delta L by L. Equate this to epsilon 2 here and simplify, you will get delta L. So delta L is this PDL by 2TE into half minus mu. So you should remember this one, delta D formula. You should remember delta L formula, then volumetric strain formula. So volumetric strain is given by change in volume divided by original volume. So change in volume is nothing but final volume minus initial volume. So original volume is area multiplied by length. Area of cylindrical shell means it is circular area. Pi square by 4 into L is the length of the cylinder. Final volume, how to get? D should be replaced by D plus delta D, because due to the pressure, there will be some deformation in the diameter, there will be some deformation in the length. That should be taken into account. So D is replaced by D plus delta D, L is replaced by L plus delta L, and multiply this, simplify, neglecting the smaller quantities, that is delta D, delta L square, delta D into delta L, delta D whole square. So those terms you have to neglect. So then you will get final volume. So take the difference between final volume and original volume. You are going to get the change in volume, delta V. Then divide the delta V by V, original volume, you are going to get the volumetric strain. So volumetric strain, after substituting and simplifying, you are going to get the expression as delta V by V is equal to volumetric strain epsilon V. You can call it as epsilon V. You can, if you want, you can write it as epsilon V. So PD by 2ET into 5 by 2 minus 2 mu. So this formula also you have to remember for doing problem. So three formulae. One is for change in diameter, second one is for change in length, third one is change in volume. So once you get volumetric strain, then you can get delta V as V into this. Okay, this is what the derivation is. Now let us see how the problems can be done. So problems are easy, direct substitution. Only thing is you should substitute the values of D, L, whatever it is, T, whatever it is, in Newton and mm, millimeters. That you have to be very careful. So one thing, if you substitute in meters, another one in centimeter, one in millimeter, then you get wrong answer. So everything what I advise you is everything you convert to millimeter. Of course, in this Example he has done in centimeter, but I advise you to convert everything to millimeter and Newton. You will get the same answer. Finally, you are going to get the same answer. Okay. So let us see how we can do the problem. Calculate the change in diameter, change in length, and change in volume of a thin cylindrical shell, 100 centimeter diameter. See, this is 100 centimeter. D is 100 centimeter. So if you convert that into millimeter, so 1000, 100 into 10. So 1000 mm. D is 1000 mm. 1 centimeter thick means 10 mm thick. 10 mm. 1 centimeter is 10 mm. And 5 meters long. 5 meters long means so 5000 millimeter long. 5000 millimeter when subjected to internal pressure of 3 Newton per mm square. That's what I told. So pressure will be given in Newton per mm square. That's why everything you convert to Newtons and millimeters. Okay. So take the value of E as 2 into 10 power 5 Newton per mm square and Poisson's ratio mu as 0.3. That is steel. It is made of steel. See, of course, this problem he has done in centimeters, but I advise you to do in millimeters. Same problem you do in millimeters. So in that case, D becomes 1000. Okay, 1000 mm. T becomes 10 mm. 1 centimeter is 10 mm. Then L becomes 1 meter means it is 5 meters means it is 5000 mm. 5000 mm. Internal pressure 3 Newton per mm square. Young's modulus 2 into 10 power 5 Newton per mm square. Poisson's ratio 0.3. Okay. Now directly you can use those formulas. So already it's direct substitution. So change in diameter is given by this formula. Just now we have derived it. Vd square by 2t into 1 minus mu by 2. But please see that when you substitute in this formula, you will be getting in millimeters. So for example, so P of course it is 3 you have to directly take 3. So there's no conversion of this. So 3 Newton per mm square, you know. So what you do is 3 into D becomes now 1000. 3 into 1000 square divided by 2 into T is here 10 mm. Okay, in millimeters we substitute into E is it is 2 into 10 power 5 Newton per mm square. No need to convert that. Directly you can substitute into 1 minus mu is 0.3 divided by 2. So what I explained now is convert everything to millimeters. So don't put it in centimeter. You convert everything into millimeter. So maybe you are going to get the answer. So into 10 will be there. That means one digit will come here. So you'll be getting the change in diameter in millimeters. The answer will be 0.6375 mm. So here you are getting 0.06376 centimeter. So if you are substituting in millimeter here, you will be getting the answer as 0.6376. So one digit will come like this. You can just try that using calculator. Similarly, change in length is given by this formula. So once again, you try to substitute in millimeters. P is 3, D is 1000, L will be 5000, divided by 2 into T will be 10, E is 2 into 10 power 5, so half minus 0.3. So if you substitute in this, you will be getting 0.075 centimeter is the answer here. When you substitute in millimeters here, you will be getting 0.75 mm. You can make a note of that. Huh? So just make a note of this answer. Then later on you can substitute and check. So 0.75 mm you are going to get. That is change in length. Then change in volume, delta V. So delta V is given by, so this simple expression. So delta V, either you can use this formula. So delta V can be found out using two formulae. Either delta V by V. Okay. So either we can use this formula for finding delta V by V. Then whatever you get, that you multiply by V. So you are going to get delta V. Otherwise, this easy method. So 2 epsilon 1 plus epsilon 2 into V gives the change in volume naturally. So see this. So delta V by V is equal to 2 epsilon 1 plus epsilon 2, you know. So what happens? So therefore the delta V will be V into 2 epsilon 1 plus epsilon 2. So that also you can use. Here in this problem, I think that is easy. So V into 2 epsilon plus epsilon 2. We know that epsilon 1 is delta D by D. Epsilon 2 is delta L by L. That we have proved already. So substitute here. Now after finding delta D and delta L, so just substitute those two values here, and volume, original volume is pi d square by 4 into L. That you can calculate. So D is Here 1000 mm, L is 5000 mm. So once you substitute, you are going to get the original volume in millimeter cube. Okay. So millimeter cube. Here he has given in centimeter cube. So you will be getting in millimeter cube. So whatever that value, you just take that value here and simplify this. You are going to get delta V in millimeter cube. Change in volume in millimeter cube. Maybe that value will be this multiplied by 10 power 3, because 1 centimeter cube is 10 power 3 millimeter cube. So you will be getting the answer into 10 power 3 millimeter cube. You can just try that. So this is the easy way of finding delta V. Otherwise, you can do in another way. So delta V by V, you can find out using this formula. So this is delta V by V. Then multiply that by V, you are going to get whatever value you are going to get. Delta V will be V into this. Okay, that also can be done. But this is easy. So delta D by D is epsilon 1. Delta L by L is epsilon 2. So just directly substitute there and simplify. You are going to get. Actually, this is epsilon 2. Please note the difference here. There's a mistake here. 2 E1 plus E2. So of course here instead of epsilon, he has written E here. So strain can be written either epsilon or E. Both are same. So different books they use different notation. That's what I told. So strain can be written as epsilon or small e, and volumetric strain is epsilon V or EV. Some books they use EV also. So this is how the problem can be given. So one more problem, let us see here. A cylindrical thin drum, 80 centimeter in diameter and 3 meters long, has a shell thickness of 1 centimeter. If the drum is subjected to an internal pressure of 2.5 Newton per mm square, determine the change in diameter, change in length, and change in volume. Similar. So it is similar type. So there is no change here. So only thing is E value and mu value has given similar type of problem. So only what you do is convert everything to millimeters. So diameter D will be now 800 mm. L will be 3000 mm, T will be 10 mm, okay, and P will be 2.5 Newton per mm square. E value is given, mu value is given. Similar procedure is followed. First you calculate delta D, change in diameter is given by this formula only. Same formula, delta D formula. Then change in length, this formula. Then change in volume, what you do is directly V into 2 epsilon 1 plus epsilon 2. So epsilon 1 is delta D by D, epsilon 2 is delta L by L. So same procedure you follow and you just substitute, you will get the answer. You will go to the next one. There is no difference, only your data is different. That's all. No? Procedure is same. The next problem, see, a cylindrical shell is 90 centimeters long. 90 centimeters long means 900 mm. 900 mm. L is 900 mm. 20 centimeter internal diameter means 200 mm D value, having thickness of metal T value 8 mm. So it is given mm only. Is filled with the fluid at atmospheric pressure. See, understand the problem. Huh? So it is filled with fluid at atmospheric pressure. If an additional 20 centimeter cube of fluid is pumped into this cylinder, so additional 20 centimeter cube means we are adding that is delta V. So additional volume we are adding. Okay, additional fluid is filled with some pressure. Okay, that is the meaning. So 20 centimeter cube, that volume of this thing is added there, pumped into the cylinder. Find the pressure exerted by the fluid on the cylinder. That means P is unknown here. Delta V he has given. Delta V is 20 centimeter cube. 20 centimeter cube means 20,000 millimeter cube. So that should be converted to millimeter. Okay, millimeter cube. So 1 centimeter is 10 mm. So centimeter cube will be 10 cube. That is 1000. So 20 into 1000, 20,000. So P is unknown here. Also compute the hoop stress induced. That is sigma 1. We have to calculate. So E and mu values are given. See here. So L is 90 centimeter means 900 mm. D is 200 mm. Thickness of cylinder 8 mm. Convert everything to millimeters. Volume of additional fluid 20 centimeter cube means 20,000 millimeter cube. Volume of initial volume Volume of cylinder is initial volume or original volume. What you can say pi d square by 4 into L. So that will be pi by 4 into 200 square into 900. Okay. So in that you will get in millimeter cube. The increase in volume it is given. Increase in volume he has given it as 20 centimeter cube. So that is the additional fluid. Whatever additional fluid we are going to pump to the cylinder, that is your delta V. So 20 centimeter cube means 20,000 millimeter cube. Now use the same formula. So use the same formula to find out P. What he has done is he has used the formula of, see here. So we know he has given delta V and V. So delta V and V are known here. So you can use this formula. So delta V is change in volume, which is 220,000 divided by V. Also you substitute in millimeter cube. So is equal to 2 epsilon 1 plus epsilon 2. So you can have this expression first. Then what he has done is he has used the expression for epsilon 1 and epsilon 2. Epsilon 1 and epsilon 2, that is hoop stress and longitudinal stress, and he has substituted that in this. So and he has simplified. You have to do this. Unless you do this, you won't get the answer. So you will be getting here the final answer. P only will be the unknown. See, this is the expression for epsilon 1 delta V by V is equal to 2 epsilon 1 plus epsilon 2. That is the formula first we are using. So you are going to get an equation like this. Then
Sir,
substitute for epsilon 1 and epsilon 2. Yes, please.
sir, question paper explain.
ಮಾಡ್ತೀನಮ್ಮ ನಾನು ಇದೊಂದು ಪ್ರಾಬ್ಲಮ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಮಾಡ್ತೀನಿ.
ಹಾ, sir.
ಯಾರು ಮಾತಾಡ್ತಾ ಇರೋದು?
ಪ್ರೀತಿ ಸರ್.
ಪ್ರೀತಿ, ಓಕೆ. ಮಾಡ್ತೀನಿ. ಇದೊಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿ ಹೇಳ್ತೀನಿ ನಾನು. ಡೌಟ್ ಕ್ಲಿಯರ್ ಮಾಡ್ತೀನಿ. ಓಕೆ. ಸೊ ಇದೆಲ್ಲ ಮಾಡ್ಬೇಕು ನೀವು. ಇದು ಮಾಡ್ಯೂಲ್ 2 ನಲ್ಲಿ ಬರುತ್ತೆ ಇದೆಲ್ಲ. ಸೊ ಯು ಕ್ಯಾನ್ ಡೂ ದಿಸ್ ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ಫಾರ್ ಎಪ್ಸಲಾನ್ 1 ಎಪ್ಸಲಾನ್ 2. ನೀವೇನ್ ಮಾಡ್ಬೋದು, ಫಸ್ಟ್ ಇಟ್ ಸೆಲ್ಫ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. Then you can substitute here also. That also you can do. Okay. Anyway, both the formula you have to use because you know the formula for this sharing alla. Yes. Is the screen visible?
Yes, sir.
Okay, okay. That's what I was telling. So problems may be given on finding the circumferential stress, longitudinal stress in thin cylinder, or finding thickness given the stress value, permissible stress value, or finding the change in is less than 1 by 20, then it becomes a thick cylinder. Then stress values, then the formulas are different. Okay, we will see that in the next class. And okay, let me see. You have asked, somebody has asked that question paper doubt. Yes. What is the doubt you have got? Tell me.
Sir, third one, sir.
You tell your name.
Shweta.
Shweta. ಹೇಳಮ್ಮ. Third
Third
question.
one, sir. ಅದರಲ್ಲಿ
ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
P4.
ಪೇಪರ್ ಕಾಣಿಸ್ತಾ ಉಂಟಾ? ಓಕೆ. ಥರ್ಡ್ ಅಲ್ಲಿ ಏನ್ ಡೌಟ್?
P4 ಹೇಗೆ ಅಂತ ಅದಕ್ಕೆ ಬರ್ಲಿಲ್ಲ ಸರ್. ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಮಾಡೋದು.
ಯಾರಿಗಾರು ಗೊತ್ತಾಯ್ತಾ? Anybody tried this?
No, sir.
ಯಾರಿಗೂ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ. ಎಂತ ಕತೆ ಇದು? Pathetic condition ಐತಲ್ಲ ಇದು. At least one of you. There are 15 students have joined. Anybody? I have done this type of problem, in the class I had explained. In the online class, so many problems I had explained. See.
ಹಾ ಸರ್, ಆದ್ರೆ ಇದೊಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾತ್ರ ಗೊತ್ತಾಗ್ತಿಲ್ಲ ಸರ್.
ಎಷ್ಟು ಬರುತ್ತೆ? P4 ಎಷ್ಟು ಬರುತ್ತೆ?
Equilibrium equation 13 something ಬರ್ತಿದೆ ಸರ್.
ಎಷ್ಟು ಬರುತ್ತೆ? 13 ಬರುತ್ತಾ? No. See, what is equilibrium equation here? P1 plus P3, alwa? P1 plus P3 should be P1 plus P3 plus P4 should be equal to P2, correct? Nodi, arrow nodi. Forces acting towards right should be equal to forces acting towards left, correct?
Yes, sir.
Equilibrium ಅಂದ್ರೆ ಅದೇ ತಾನೆ. ಈಗ P1 is acting towards right, so P1 plus P3 plus P4 should be equal to P2. ಅದನ್ನ ಹಾಕಿ ಏನ್ ಬರುತ್ತೆ ನೋಡಿ, ಇದರಲ್ಲಿ P1 ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದಾರಲ್ಲ 10. So according to this, 10 plus P3 is 12, 22 ಆಯ್ತು. 10 plus 22 ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು? 10 plus 12, 22 ಆಯ್ತು. ಸೊ 22 plus P4 should be equal to 10 ಅಂತ ಬರುತ್ತೆ. 15 ಅಂತ ಬರುತ್ತೆ, ಕರೆಕ್ಟಾ? ಸರಿ, ನಾ ಬರ್ಕೊಳ್ಳಿ, ಅವ್ರ ಪೇಪರ್ ಮೇಲೆ ಬರ್ಕೊಳ್ಳಿ, ಇದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ ಅದು. ಸೊ P1 is 10, ಸೊ 10 plus 12, 22 ಆಯ್ತು, ಪ್ಲಸ್ P4 is equal to P2. ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ. P4 ಎಷ್ಟು ಬರುತ್ತಾಗ? ಎಷ್ಟು ಬರುತ್ತೆ P4?
7 ಸರ್, -7.
-7 ಬರುತ್ತೆ ನೋಡಿ. ಅಲ್ಲ, ನೀವೆಲ್ಲ ಇಂಜಿನಿಯರ್ಸ್ ಅಲ್ವಾ? ನೀವು ಇಂಜಿನಿಯರ್ಸ್, ನೀವು 1ನೇ ಕ್ಲಾಸ್ 2ನೇ ಕ್ಲಾಸ್ ಅಲ್ಲ, ಗೊತ್ತಾಯ್ತಾ? ಮೈನಸ್ ಬರುತ್ತೆ. ಏನಾದ್ರ ಅರ್ಥ ಮೈನಸ್ ಬಂದ್ರೆ? P4
ಸರ್ ಅದು ಆಪೋಸಿಟ್ ಇದೆ ಅಂತ.
ತಕೋಬೇಕು, ಆಪೋಸಿಟ್ ನೀವು ತಕೋಬೇಕು. ನೀವು ಇಂಜಿನಿಯರ್ಸ್ ಅಲ್ವಾ? ನೀವೆಲ್ಲ ಬುದ್ಧಿವಂತರು ತಿಳ್ಕೊಂಡಿದ್ನಪ್ಪ ನಾನು. ಯಾರು ಬುದ್ಧಿವಂತ ಅಲ್ಲ. ನೀವು ಕಾಗೆ ಬೆಳ್ಳಗಿದೆ ಅಂದ್ರೆ ಹೂ ಅಂತ ಗೊತ್ತಿರಲ್ಲಪ್ಪ. ಕಾಗೆ ಬೆಳ್ಳಗಿದೆ, ಮಾರ್ಷ್ ಹೇಳಿದ್ರು ಕಾಗೆ ಬೆಳ್ಳಗಿದೆ, ಕಾಗೆ ಬೆಳ್ಳಗಿದೆ. ಹಾಗೇನ್ ಮಾಡ್ಬೇಕು ನೀವು? P4 ಹಿಂಗಿದೆಯಲ್ಲ, ಟೆನ್ಷನ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಟೆನ್ಷನ್ ಕೊಟ್ಟಿದೆ ಅಲ್ವಾ?
ಎಸ್ ಸರ್.
ಅದೇನಾಗ್ತದೆ?
ಕಂಪ್ರೆಸ್.
ಮೈನಸ್.
ಇವಾಗ ಗೊತ್ತಾಯ್ತು ಸರ್, ನೆಕ್ಸ್ಟ್ ಮಾಡ್ತೀನಿ ಬಿಡಿ.
ಮುಂದೆ ಮಾಡ್ತಾ ಹೋಗಿ, ಗೊತ್ತಾಯ್ತಾ?
ಹಾ ಸರ್.
10 ಮಾರ್ಕ್ ಹೋಯ್ತಲ್ಲಮ್ಮ. ಎಂತ ಅಲ್ಲ,
ಪಾಯಿಂಟ್ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಸರ್.
ಇದನ್ನ ಲಾಜಿಕಲ್ ಅಂತ ಹೇಳೋದು. ನೀವು ಇಂಜಿನಿಯರ್ಸ್ ಕೆಲಸ ಇದು, ಗೊತ್ತಾಯ್ತಾ? ಇಲ್ಲಾಂದ್ರೆ ಕಾರ್ಖಾನೆಯಲ್ಲಿ ರೋಡಲ್ಲಿ ಹೋದವರು 1+2=3 ಅಂತ ಹೇಳ್ತಾರಪ್ಪ. ನಿಮ್ಗೂ ಡಿಫ್ರೆನ್ಸ್ ಏನು ಅಲ್ವಾ?
ಹೌದು ಸರ್.
ಇದನ್ನ P4 ನ 7 ಕಂಪ್ರೆಸಿವ್ ತಗೋಬೇಕು, ಗೊತ್ತಾಯ್ತಾ? ತಗೊಂಡ್ ಮಾಡಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇನ್ನೇನ್ ಡೌಟ್ ಇದೆ? ಇನ್ಯಾವುದೋ ಒಂದು ಕ್ವಶನ್ ಒಂದು ಡೌಟ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ. ನೀವು ಯಾರು ಸೀರಿಯಸ್ ಆಗಿ ಓದಿಲ್ಲಪ್ಪ, ನೀವು ಕಾಲೇಜಿಗೆ ಬರೋಂಗಾಗ್ಬೇಕು. ಇದು ಇನ್ನೊಂದು ಕ್ವಶನ್ ನಲ್ಲಿ ಏನೋ ಒಂದು ಇದಿದೆ, ಏನಂತ ಹೇಳಿ ಯಾರು ಅಬ್ಸರ್ವ್ ಮಾಡಿಲ್ವಾ? ಇವತ್ ಲಾಸ್ಟ್ ಡೇಟ್ ಅಲ್ಲ ಕೊಡ್ಲಿಕ್ಕೆ ನಿಮ್ಗೆ, ಇನ್ನೂ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ನೀವು?
ಅಸೈನ್ಮೆಂಟ್ ಕೊಟ್ಟಿರೋದು ಮುಗ್ದಿದೆ ಸರ್. ಇದು
ಅದೇ, ಇದರಲ್ಲಿ ಎಷ್ಟು ಕ್ವಶನ್? ನಿಮ್ಗೆ 5-6 ಕ್ವಶನ್ ಇದೆ ಅಷ್ಟೇ ಅಲ್ವಾ? ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾತ್ರ ಮಾಡ್ಬೇಕು ನೀವು, ಥಿಯರಿ ಬೇಡ, ಆಯ್ತಾ? 1, 2, 3, 4, 5, 6, 7 ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. 7, 8 ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಇರ್ಲಿ, ಅದೆಲ್ಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿರೋದೇ ನಾನು. ನೀವು ನೋಟ್ಸ್ ಅಲ್ಲಿ ನೀಟಾಗಿ ನೋಡಿದ್ರೆ ಮಾಡ್ತಾ ಹೋಗ್ಬೋದು. ಇದರಲ್ಲಿ ಇನ್ನೂ ಒಂದು ಡೌಟ್ ಯಾರಿಗೂ ಬರಲಿಲ್ವಾ? ಇನ್ನೊಂದು ಕ್ವಶನ್ ಅಲ್ಲಿ ಡೌಟ್ ಬರುತ್ತೆ ಇದರಲ್ಲಿ. ಇದೊಂದು ಓಕೆ, P4 ಕಂಪ್ರೆಸಿವ್ ಆಗುತ್ತೆ, 7 ತಗೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಒನ್ ಮೋರ್ ಡೌಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್. ಯಾವ ಕ್ವಶನ್ ಅಲ್ಲಿ? ಇದರಲ್ಲಿ ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ರ, 30 ತಗೊಂಡ್ ಮಾಡಿದಾರೆ ಎಲ್ಲ, ಸುಮಾರು ಜನ 300ಗೆ 30 ಹಾಕೊಂಡಿದೆ. ಅದಕ್ಕೆ ವ್ಯಾಲ್ಯೂ ಬೇರೆ ಬಂದಿದೆ, ಯಂಗ್ಸ್ ಮಾಡ್ಲೆಸ್. ಒಂದು ಡಿಜಿಟ್ ಮುಂದೆ ಕಮ್ಮಿ ಆಗಿದೆ. ಅದು ಬಹಳ ಕೇರ್ಫುಲ್ ಆಗಿರ್ಬೇಕು ನೀವು. ಯು ಶುಡ್ ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್ ಇನ್ ದಟ್. ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಇನ್ ವಾಲ್ಯೂಮ್ ಇದು ಮಾಡಿದ್ದೀರಾ, ಎಲ್ಲರೂ ಮಾಡಿದ್ದೀರಾ? ಇದರಲ್ಲಿ 2B ಮಾಡಿದ್ದೀರಾ ಎಲ್ಲ? ಎನಿಬಡಿ ಹೂ ಹ್ಯಾಸ್ ಡನ್, ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಟೆಲ್ ಮೀ. 2B ಅಲ್ಲ, ಸಾರಿ, 1D ನಲ್ಲಿ 1D ನಲ್ಲಿ ನೋಡಿ, ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಸ್ಟ್ರೆಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಕೇಳಿದೀನಿ. ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್, ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ, ಪರ್ಸೆಂಟೇಜ್ ಅಲಾಂಗೇಷನ್, ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್. ಇದನ್ನ ಮೋಸ್ಟ್ ಆಫ್ ಯು ಮಾಡೇ ಇಲ್ಲ ನಿಮ್ಗೆ, ಬಟ್ ಕೆಲವ್ರು ಮಾಡಿದ್ದಾರೆ, ಕೆಲವ್ರು ಟ್ರೈ ಮಾಡಿದ್ದಾರೆ. ಇದು ನೀವು ಮಾಡಿ ನೋಡಿ, ಮತ್ತೆ ನಿಮ್ಗೆ ಡೌಟ್ ಬರ್ಬೋದು. ನೋಡೋಣ, ಬಂದ್ರೆ ಯಾರಿಗೆ ಡೌಟ್ ಬರುತ್ತೆ ಅವರು ಕೇಳಿ ನೋಡೋಣ. ನೀವು ಟ್ರೈ ಮಾಡ್ಬೇಕು, ಟ್ರೈ ಮಾಡಿದ್ರೆ ಅದು ಗೊತ್ತಾಗುತ್ತೆ. ಆ ಡೇಟಾ ಏನೇನು ಗೊತ್ತಾ ಇಲ್ಲಿ ನೋಡಿ. 25 mm ಡಯಾಮೀಟರ್ ಅಂದ್ರೆ D ಇನಿಷಿಯಲ್ ಡಯಾಮೀಟರ್, ಅದು ಗೇಜ್ ಲೆಂತ್ ಅಂದ್ರೆ L 200 mm. ಓಕೆ, ಎಕ್ಸ್ಟೆನ್ಷನ್ ಆಫ್ 0.155 mm ಅಂಡರ್ ಎ ಲೋಡ್ ಆಫ್ 78 ಅಂದ್ರೆ P78 kN, ನ್ಯೂಟನ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಎಕ್ಸ್ಟೆನ್ಷನ್ ಅಂದ್ರೆ ಡೆಲ್ಟಾ L. ಓಕೆ, ಲೋಡ್ ಅಟ್ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಇಸ್ 165 kN, ಮ್ಯಾಕ್ಸಿಮಮ್ ಲೋಡ್ ಇಸ್ 245 kN. ಸೊ ನಿಮ್ಗೆ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಸ್ಟ್ರೆಸ್ ಇದೆಯಲ್ಲ, ಇದನ್ನ ಕಂಡುಹಿಡಿಯಲಿಕ್ಕೆ ಈ ಲೋಡ್ ತಗೊಳ್ಬೇಕು ನೀವು. ಸ್ಟ್ರೆಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ದಿಸ್ ಲೋಡ್ 165 into 10 power 3 ಡಿವೈಡ್ ಬೈ ಏರಿಯಾ. ಏರಿಯಾ ಗೊತ್ತಲ್ಲ 5/4 into d ಸ್ಕ್ವೇರ್ ಮಾಡಿ, ಅವಾಗ ಇದು ಸಿಗುತ್ತೆ, ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಸಿಗುತ್ತೆ. ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಯಾವುದು, ಡೆಲ್ಟಾ ಎಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಎಲ್ ಬೈ ಎ. ಅವಾಗ ಯಾವುದು ಇ ಪಿ ಯೂಸ್ ಮಾಡಬೇಕು. 78 ಕಿಲೋಮೀಟರ್ ಇದೆಯಲ್ಲ, ಇದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು. ಡೆಲ್ಟಾ ಎಲ್ ಇದು 0.155 mm ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ 78 into 10 power 3 ಎಲ್ 200 ಡಿವೈಡ್ ಬೈ ಎ ಅಂದ್ರೆ 5d²/4 ಇಂಟು ಇ. ಸೊ ಅವಾಗ ಇ ಅನ್ನೋನು ಇ ಕಂಡುಹಿಡಿಬಹುದು. ನೆಕ್ಸ್ಟ್ ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ ಕಂಡುಹಿಡಿಯಕ್ಕಾಗತ್ತಾ ನೋಡಿ. ನೆಕ್ಸ್ಟ್ ಪರ್ಸೆಂಟೇಜ್ ಎಲಾಂಗೇಶನ್ ಗೊತ್ತಲ್ಲ ನಿಮ್ಗೆ. ಪರ್ಸೆಂಟೇಜ್ ಎಲಾಂಗೇಶನ್ ಏನು, ಹೌ ಡು ಯು ಗೆಟ್ ದಿ ಪರ್ಸೆಂಟೇಜ್ ಎಲಾಂಗೇಶನ್? ಟೋಟಲ್ ಎಲಾಂಗೇಶನ್ ಇದೆಯಲ್ಲ, ಟೋಟಲ್ ಎಕ್ಸ್ಟೆನ್ಷನ್ 58 ಇದೆಯಲ್ಲ. ಸೊ ಇದನ್ನ ನೀವು ಒರಿಜಿನಲ್ ಲೆಂತ್ಗೆ 200ಗೆ ಆಡ್ ಮಾಡಿ. ಸೊ 200 + 58 258 mm ಈಸ್ ಯುವರ್ ನ್ಯೂ ಲೆಂತ್ ಅಲ್ವಾ. ಸೊ ಪರ್ಸೆಂಟೇಜ್ ಎಲಾಂಗೇಶನ್ ಅಂದ್ರೆ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಇದು ತಗೋಬೇಕು ನೀವು 58 mm ಫೈನಲ್ ಲಾಸ್ಟ್ ಅಲ್ಲಿ. ಸೊ 58 mm ಡಿವೈಡೆಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಲೆಂತ್ 200. ಸೊ 58 divided by 200 into 100. That is percentage elongation. ಅಂದ್ರೆ ಫೈನಲ್ ಲೆಂತ್ ಮೈನಸ್ ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಡಿವೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಇಂಟು 100. ಅದು ಪರ್ಸೆಂಟೇಜ್ ಎಲಾಂಗೇಶನ್. ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾ ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಏರಿಯಾ ಮೈನಸ್ ಫೈನಲ್ ಏರಿಯಾ. ಫೈನಲ್ ಏರಿಯಾ ಹೇಗೆ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ? ಫೈನಲ್ ಏರಿಯಾ ಹೇಗೆ ಸಿಗುತ್ತೆ ನೋಡಿ, ಡಯಾಮೀಟರ್ ಫ್ರಾಕ್ಚರ್ ಕೊಟ್ಟಿದ್ದಾನಲ್ಲ 18.8 ಅಂತ. ಸೊ ಇನಿಷಿಯಲ್ ಏರಿಯಾ 5/4 into 25 square, ಫೈನಲ್ ಏರಿಯಾ 5/4 into 18.8 square. ಸೊ ಅವಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಇನಿಷಿಯಲ್ ಏರಿಯಾ ಮೈನಸ್ ಫೈನಲ್ ಏರಿಯಾ ಡಿವೈಡೆಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಏರಿಯಾ ಇಂಟು 100. ಅದು ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾ. ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ ಏನ್ ಡೆಫಿನೇಷನ್ ಹೇಗೆ ಕಂಡಿದ್ದೀರಾ? ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ ಹೌ ಡು ಯು ಫೈಂಡ್ ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ? ಎನಿಬಡಿ ಡೆಫಿನೇಷನ್ ಏನು ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋಗೆ?
ಸರ್ ಲ್ಯಾಟ್ರಲ್ ಸ್ಟ್ರೈನ್ ಡಿವೈಡೆಡ್ ಬೈ
ಹಾ,
ಲೀನಿಯರ್ ಸ್ಟ್ರೈನ್
linear strain,
ರೇಷಿಯೋ.
ಲ್ಯಾಟರಲ್ ಸ್ಟ್ರೈನ್ ಅಂದ್ರೆ ಏನು? ಲ್ಯಾಟರಲ್ ಸ್ಟ್ರೈನ್ ಅಂದ್ರೆ ಚೇಂಜ್ ಇನ್ ಡಯಾಮೀಟರ್ ಡಿವೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಡಯಾಮೀಟರ್ ಅಲ್ವಾ? ಕರೆಕ್ಟ್ ತಾನೆ? ಲ್ಯಾಟರಲ್ ಅಂದ್ರೆ ಏನು? ಲ್ಯಾಟರಲ್ ಅಂದ್ರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಲೆಂತ್ ಯಾವ್ದಿರುತ್ತೆ, ಡಯಾಮೀಟರ್ ಇರ್ತದೆ. ಸೊ ಚೇಂಜ್ ಇನ್ ಡಯಾಮೀಟರ್ ಡಿವೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಡಯಾಮೀಟರ್, ಅದು ಲ್ಯಾಟರಲ್ ಸ್ಟ್ರೈನ್. ಲೀನಿಯರ್ ಸ್ಟ್ರೈನ್ ಅಂದ್ರೆ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಡಿವೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಲೆಂತ್. ಸರಿನಾ? ಅರ್ಥ ಆಯ್ತಾ?
ಸರ್
ಹೇಳಿ.
ಡಯಾಮೀಟರ್ ಅಟ್ ಫ್ರಾಕ್ಚರ್ ಅಂದ್ರೆ
ಹಾ
ಏನು?
ಸರ್, ಎಸ್ ಸರ್.
ಡಯಾಮೀಟರ್ ಫ್ರಾಕ್ಚರ್ ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಅದು ಫೇಲ್ ಆಗುತ್ತಲ್ಲ ಟೆಸ್ಟ್ ಮಾಡಿದಾಗ, ಯಾವ್ದು ಲೋಡ್ ಯಾವ್ದೋ ಒಂದು ಲೋಡ್ ಅಲ್ಲಿ ಫೇಲ್ ಆಗುತ್ತೆ. ಅದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಲ್ಲ, 245 ಅಲ್ಲ, ಅದು ಅಲ್ಟಿಮೇಟ್. ಅದು ಅದಾದ್ಮೇಲೆ ಡೌನ್ ಕರ್ವ್ ಹೇಳಿದ್ದೀನಲ್ಲ ನಿಮ್ಗೆ, ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೈನ್ ಕರ್ವ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಕರ್ವ್ ಬರುತ್ತೆ, ಆಮೇಲೆ ಕಮ್ಮಿ ಆಗಿ ಜಾಸ್ತಿ ಆಗಿ ಮತ್ತೆ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಅಂದ್ರೆ ಈಗ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಡಯಾಮೀಟರ್ ಫ್ರಾಕ್ಚರ್ ಕೊಟ್ಟಿರೋದು ಇದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ಕೆ, ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾಗೆ. ಅದು ಟು ಫೈಂಡ್ ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾ ವಿ ನೀಡ್ ದಟ್ ಡಯಾಮೀಟರ್. ಯಾಕೆಂದ್ರೆ ಫೈನಲ್ ಏರಿಯಾ ಬೇಕಲ್ಲ. ಫೈನಲ್ ಏರಿಯಾ 5/4 into 18.8 square, ಇನಿಷಿಯಲ್ ಏರಿಯಾ 5/4 into 25 square. ಇನಿಷಿಯಲ್ ಏರಿಯಾ ಮೈನಸ್ ಫೈನಲ್ ಏರಿಯಾ ಡಿವೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಏರಿಯಾ ಇಂಟು 100 ಪರ್ಸೆಂಟೇಜ್ ಅಲ್ಲಿ ಸಿಗುತ್ತದೆ. ಬಟ್ ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ ಕಂಡುಹಿಡಿಯಕ್ಕಾಗತ್ತಾ ನೋಡಿ ಈ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ? ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು, ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಸ್ಟ್ರೆಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು, ಪರ್ಸೆಂಟೇಜ್ ಎಲಾಂಗೇಶನ್, ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಕ್ಯಾನ್ ವಿ ಫೈಂಡ್ ಔಟ್ ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ? ಸೊ ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ ಇಸ್ ಲ್ಯಾಟರಲ್ ಸ್ಟ್ರೈನ್ ಡಿವೈಡ್ ಬೈ ಲೀನಿಯರ್ ಸ್ಟ್ರೈನ್. ಸೊ ಲೀನಿಯರ್ ಸ್ಟ್ರೈನ್ ಅಂದ್ರೆ ಡೆಲ್ಟಾ ಎಲ್ ಬೈ ಎಲ್, ಲೀನಿಯರ್ ಸ್ಟ್ರೈನ್. ಓಕೆ. ಲ್ಯಾಟರಲ್ ಸ್ಟ್ರೈನ್ ಅಂದ್ರೆ ಡೆಲ್ಟಾ ಡಿ ಬೈ ಡಿ, ಡಯಾಮೀಟರ್ ತಗೊಳ್ಬೇಕು. ಚೇಂಜ್ ಇನ್ ಡಯಾಮೀಟರ್ ಡಿವೈಡ್ ಬೈ ಇನಿಷಿಯಲ್ ಡಯಾಮೀಟರ್, ಅವೆರಡಕ್ಕೂ ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ ಆಗ ಅದು ಪಾಯ್ಸನ್ಸ್ ರೇಷಿಯೋ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ನೋಡೋಣ, ಅದು ಮಾಡಿ ಟ್ರೈ ಮಾಡಿ ನೋಡೋಣ. ಓಕೆ, ಅಷ್ಟೇ, ಇನ್ನೇನು ಡೌಟ್ ಇಲ್ಲ ಇದರಲ್ಲಿ. ಸೊ ವರ್ಕ್ಔಟ್ ಆಲ್ ದಿ ಪ್ರಾಬ್ಲಮ್. ಸೊ ಆ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ P4 ಕಂಪ್ರೆಸಿವ್ ಆಗುತ್ತೆ, 7 ಬರುತ್ತೆ. -7 ಅಂದ್ರೆ ಕಂಪ್ರೆಷನ್. ಅದೇ -7 ಅಂದ್ರೆ ಆರೋ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಬೇಕು ನೀವು ಫಿಗರ್ ಅಲ್ಲಿ. ಎಕ್ಸಾಮ್ ಕೊಡ್ತಾರೆ, ನೀವು ಕೇರ್ಫುಲ್ ಇರ್ಬೇಕು. ಅದನ್ನ ಯಾವಾಗ ಅದ್ರ ಅರ್ಥ ಅಷ್ಟೇನೆ, ನೆಗೆಟಿವ್ ಬಂದ್ರೆ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ತಗೊಂಡು ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. ಕಂಪ್ರೆಷನ್ ಆದಾಗ ಏನಾಗ್ತದೆ, ಇದರಲ್ಲಿ ಕಂಟ್ರಾಕ್ಷನ್ ಆಗ್ತದೆ ಈ ಬಾರ್ ಅಲ್ಲಿ ಅಲ್ವಾ, ಡೆಲ್ಟಾ ಎಲ್ ನೆಗೆಟಿವ್ ಆಗುತ್ತಾಗ ಇದರಲ್ಲಿ ಅಲ್ವಾ, ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಡೆಲ್ಟಾ L3 ಮೈನಸ್ ಬರುತ್ತೆ. ಸೊ ಡೆಲ್ಟಾ L1 ಪಾಸಿಟಿವ್ ಇದ್ದು ಡೆಲ್ಟಾ L2 ಪಾಸಿಟಿವ್ ಇದ್ದು ಡೆಲ್ಟಾ L3 ನೆಗೆಟಿವ್ ಬರುತ್ತೆ. ಹಂಗ್ ಮಾಡಿ ಅದ್ ಮಾಡಿದಾಗ ಮೂರನ್ನ ಆಡ್ ಮಾಡಿದಾಗ, ಆಡ್ ಅಂದ್ರೆ ಇದು ಸಬ್ಟ್ರಾಕ್ಟ್, ಡೆಲ್ಟಾ L3 ವಿಲ್ ಬಿ ನೆಗೆಟಿವ್. ಇದು ಎಷ್ಟೆಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ, ನೀವು ಅದನ್ನ ಹಾಕೊಳ್ಬೇಕು. ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಈಚ್ ಸೆಗ್ಮೆಂಟ್ ಸೆಪರೇಟ್ಲಿ, write down the free body diagram and find out the forces acting on each portion. ಆಯ್ತಾ, ಅದು ಮಾಡಿ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾನು ಥಿಕ್ ಸಿಲಿಂಡರ್ಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ. ಅದೊಂದು 2 ಕ್ಲಾಸ್ ಬೇಕಾಗುತ್ತೆ. ಅದಾದ್ಮೇಲೆ ಫೇಲ್ಯೂರ್ ಥಿಯರಿ ಅಂತ 2 ಇದೆ, ಅದಕ್ಕೆ 1 ಕ್ಲಾಸ್ ಬೇಕು. ಸೊ ಒಟ್ಟಿನಲ್ಲಿ 3 ಕ್ಲಾಸ್ ಬೇಕು ಯೂನಿಟ್ 2 ಮುಗಿಲಿಕ್ಕೆ, ಮಾಡ್ಯೂಲ್ 2 ಮುಗಿಲಿಕ್ಕೆ. ಸೊ SOM ಲೆಂತಿ ಸಬ್ಜೆಕ್ಟ್. ಸೊ ನೀವು ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಿದ್ರು ಸಾಲೋದಿಲ್ಲ, ಗೊತ್ತಾ? ಯು ಹ್ಯಾವ್ ಟು ಬಿ ಕೇರ್ಫುಲ್. ತುಂಬಾ ವರ್ಕ್ ಹೆಚ್ಚು ಮಾಡಿದಷ್ಟು ಒಳ್ಳೇದು. ನಿಮ್ಗೆ ತುಂಬಾ ಮೆಟೀರಿಯಲ್ ಅಂತೂ ಕಳಿಸ್ಕೊಡ್ತಿದ್ದೀನಿ, ಕ್ಲಾಸಸ್ ಕೂಡ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನೀವು ಜಾಯಿನ್ ಆಗ್ಬೇಕು. ಯಾರು ಜಾಯಿನ್ ಆಗೋದಿಲ್ಲ ಅವ್ರ ಕಷ್ಟ ಆಗ್ತದೆ, ಅರ್ಥ ಆಗುದು. ಆಲ್ ಆಫ್ ಯು ಶುಡ್ ಬಿ ಪ್ರೆಸೆಂಟ್. ಇಫ್ ಯು ಲೂಸ್ ದಿ ಕ್ಲಾಸ್ ದೆನ್ ಯು ವಿಲ್ ನಾಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ವೆರಿ ಡಿಫಿಕಲ್ಟ್, ನೋಟೇಶನ್ಸ್ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ ಎಲ್ಲ. ಎಸ್, 1828.
Present, sir.
1830.
Yes, sir.
19002.
Yes, sir.
003. 003 Ajay Kumar.
Yes, sir. Yes, sir.
5 Darshan.
Present, sir.
6 Divyashri.
Present, sir.
7 Janavi.
Present, sir.
10 Padma.
Present, sir.
11 Preeti.
Present, sir.
12 Rahul.
Present, sir.
13 Medhesh.
Present, sir.
16 Sri Lakshmi.
Yes, sir.
17 Shrey.
Present, sir.
Twenty-one Surya. Sri Lakshmi
Sir,
present.
Shweta present, sir.
ಆಯ್ತು ಆಯ್ತು, ಈಗ ಕಾಣಿಸ್ತಾ ಇದ್ದೀರಾ?
Yes, I am
Voice
present.
ಹಾ,
ಕಟ್
ಶ್ರೇಯಸ್.
ಆಗ್ತಿತ್ತು ಸರ್.
ಕಟ್ ಆಗುತ್ತೆ, ಏನೋ ಪ್ರಾಬ್ಲಮ್. ಇಲ್ಲಿದೆ, ಇಲ್ಲಿ ನಿಮ್ಮ ನಂಬರ್ ಉಂಟು, ಇಟ್ ಈಸ್ ಆನ್ ದಿ ಸ್ಕ್ರೀನ್. ಏನಂದ್ರೆ ನೀವು ಮಲಗ್ಬಿಟ್ಟಿದ್ದೀರಾ, ನಿದ್ದೆ ಮಾಡ್ತೀರಾ, ಎದ್ದಿದ್ದೀರಾ ಅಂತ ಚೆಕ್ ಮಾಡ್ಲಿಕ್ಕೆ. ಶ್ರೇಯಸ್
ಇಲ್ಲ
ಗೌಡ
ಸರ್, ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್.
ಸೂರ್ಯ ಗೌಡ ಪ್ರೆಸೆಂಟ್. ಓಕೆ, ಆಯ್ತು. ಸೊ ಸ್ಟಡಿ ಮಾಡ್ಬೇಕು ನೀವು. ಸಾಲಲ್ಲ, ಫಸ್ಟೆಸ್ಟ್ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ನಾಟ್ ಗುಡ್, ನಾಟ್ ಹ್ಯಾಪಿ. ಎಲ್ಲರೂ 3 ಕ್ವಶನ್ ಮಾತ್ರ ಬರ್ದಿದ್ದೀರಪ್ಪ, 2 ಕ್ವಶನ್ ಯಾಕೆ? Okay, I will leave the meeting.
Thank you, sir.